Stairs are a big component of home projects. Whether or not you're finishing your basement, you're building a deck, maybe you've got a storage unit, an upper loft in a garage or something, stairs are part of that. And before we dive into just kind of the nuances of new stairs, let's talk first about existing stairs. So at least since I've been doing inspections, at least when I very first started where I'm at, they were pretty diligent on the fact that if you have existing stairs and you tear them out, you need to then build them to code. It's like, whoa, well, if I got to build them to code and they're not now, maybe the head height that I have, I can't get with my existing floor. I can't get the rise and run. Maybe I can't get the landing that I need. So what I would tell you is make sure that wherever you're at, that you check with your building department and find out what their requirements are for existing stairs. And this was, as the years have gone on, as an inspector, where I'm at, we've started to get a little bit more lenient on rebuilding poorly built or just beat up stairs that are not safe. They're not necessarily building them to code, but they're building them as much as possible to code. So the rise and the run are as close to code as possible. The landings are as close as we can get them, but they're in general much safer. Now, usually we ask the homeowner or contractor to contact us first so we can look at it and help make kind of a group decision on what to do. This way, you guys don't go and build something that then will get turned down or you'll have to make a whole bunch of adjustments to it. I want you to be able to have the information you need to build stairs to code as much as possible, and to have an idea of what's needed. Now, stairs can be stairs, like I said, in homes or on decks or anywhere. This would be general requirements for residential construction. So anything related to a house or connected to it or anything like that, this would be the code requirements for that. When you get into commercial has a little bit different requirements as far as rise and run is concerned. You might have heard 7 and 11. 7 and 11 is commercial. The rise is a max of 7 inches and the run, the tread depth, is 11. When we get into residential, the rise is 7 3/4 max and the run is 10 inches minimum. And I'm going to jump into some pictures here before I get into the code and kind of just run you through so you know what I'm talking about. Rise and run, treads, risers, stair nose, stuff like that. I want to make sure that you have the terminology. So when you go build your stairs or you're fixing them or whatever it is that you're doing, you have a clear understanding of what you need to know so you can build them right the first time. So first of all, this would be just a quick little illustration of rise and run. So you have a riser, which is the same thing as a rise, right? The riser is the height at which each stair rises. For residential, it's 7 3/4 max with a 3/8 inch difference in the run of stairs. So for example, this particular rise couldn't be 7 inches and then this one couldn't be 6. They have to all be within 3/8 of an inch difference. And I will tell you that typically when we got people cut their stringers, everything is good to go. It's the bottom step and the top step that most people have issues with because they don't take into account the added tread right here, which then makes this higher, or they don't forget that this already has it and then it might make this a little bit shorter. So just when you're doing it, make sure you run all your numbers so that when your finished product's done, everything is within 3/8 of an inch. When it comes to tread, it's 10 inches minimum. And then this right here is what they would call a stair nose. Stair nose needs to stick out. I believe it's like 3/4 to 1 1/4 inches. So all stairs should have a stair nose. And so when you design for it, you can see how each stair has a nose. But the tread itself is 10 inches. Okay? And then here would be your stair nose. You can see they put a toe plate in. And then they have, this is what you would call your stringer. And then this would be like a header or a beam or something that's at the top of the stairs where the landing is. Sometimes you might drop down onto a landing and then turn a corner and come down again. and then there would be a beam that sits underneath here that the next set of stairs would lay up against. Now you can see how these stringers are fully backed up against this beam, right? This beam is holding that weight, and then it's got this toe plate right here to keep it from kicking out, right? Here, the quality of this is not very good, but what I want to show you is this right here. Because a lot of times people want to drop down a step immediately, right? So they can go up to 7 3/4. Well, when you do that, depending on how thick your floor is, you don't have a lot of structural component that these stringers are bearing up against, that they're leaning up against. See right here, there's just a little bit. And if you do that, not that that's bad, you just need to make sure that these stairs are structurally sound. A lot of times guys will go and put a metal hanger or a metal, they have like specific hangers for stair stringers. They'll take a strap and run it from the bottom all the way up and nail it on the back side of this header. They might add a wall underneath here. Maybe it's a storage area, and so you can frame a wall with a header on it and have a doorway to go underneath. And then you're adding support directly underneath these stringers. I myself, and this is more of an opinion-based thing, I have a hard time believing that right there, that component is structurally sound. I don't even like just straps, but we'll call straps, and we'll make sure that they have metal straps that connect everything together. I like to see some type of pony wall under it, or some type of beam. I like to know that it's really secure. This little toe kick right here, this toe plate, helps a lot as well. If it's on concrete, you can ram set it or anchor bolt it in, and then it's going to keep those stairs from kicking out as well. Now, granted, you're going to have this connection. You're probably going to have this toe plate connection. And then if these aren't just open on all sides, if there's a wall on one side, you're going to nail your stringers off to the wall going down. If there's walls on both sides, you're going to nail it off, and that's going to help make it, structurally sound as well. I just have a really hard time with this particular connection right here when it's built like this. I like to know it's good and solid. So that would kind of cover rise and run, right? So 7 3/4 max with 3/8 inch difference. You need a tread of 10 inches. You need to have a stair nose. You need to make sure that the stringer, which is the structural component of the stairs, usually you'll have 3 or 4 of them, 3 minimum, in my opinion. I like to see 4 because it just keeps the floors from bouncing, but it depends on your budget. A lot of houses are built with 3 and they do just fine. So again, we're back here to the stringers. You can see right here, like I'm talking about, this one little spot right here where there's not a lot of connection point there. So if you had like some type of wall that's built under here just to help hold them up, if you have the ability, ideal. Head height, 6 foot 8 inches. This is your stair nose right here. So when you're measuring 6 foot 8, right, you should have 6 foot 8 at any point along here. Well, the farthest point sticking out is your nose. So if you measure up 6 foot 8, you're good to go. If you've got a full 6 foot 8 head height going all the way down, this is where existing houses can get into trouble. Let's just say that this is not built to code. Maybe you only have 8 inch treads, and you have like 9 inch risers, right? They're just really high steps. Well, if you had to drop that down to 7 3/4 and 10 inch treads, it would push the stairs out way out here. Well, all of a sudden your head height, you don't have it anymore. So if it's existing stairs, make sure you check with your building department, because they might tell you, look, we would rather you build it back exactly the way it was, or make sure all your risers are exactly 9 inches and keep your head height. Or they might say, hey, let's make sure we got a 6 foot head height, and then see what you can get on your risers and see if you can get them down closer to 8. Knowing that code is 7 3/4, we want to get as close to that as possible. So here's an illustration that kind of runs through a bunch of the code requirements. So here is our 10 inch tread. Here's our 7 3/4 inch max rise, and we're talking about residential. Here they've suggested 3 2x12 stringers. And I'm talking about just stairs and landings right now. You'll see in here I've got a bunch of guard and handrail stuff, which I'll dive into the next video on. But I don't want to overblow you on this particular video, just when we're dealing with stairs and landings. So here's our 6'8" minimum clearance. And then you'd have your landing here at the bottom and a landing here at the top. There are some exceptions on landings, but in general, a landing is as wide as the stairs, usually 3 feet, and 3 foot out. So a 3x3 landing is very common, and it needs to be at the bottom of all stairs and typically at the top of all stairs. Usually if you walk out into a hallway at the top of the stairs, well, there's your landing. You walk into the bottom, there's your landing. If it's outside, if it's a deck, and you walk down onto the ground, well, you're going to need some type of landing down there. It has to be a solid surface. Pavers, concrete, something along those lines, and not grass, right? It needs to be solid. And that's where, like on decks, you can get in a little bit of that bottom riser can get real touchy when you're doing your measurements, because wherever that, if you haven't already poured that landing and you've built your stairs, well, now you need to measure and make sure that your landing is right where it needs to be. I've had people put them in and it's like, oh, you've got like a 9-inch riser on the very first rise, and then everything else is like 7.5. So then they've got to come in and they got to raise their grade or mess with it to try to get everything equal, because you don't want that tripping hazard. You don't want that feeling of walking up different riser heights. You want everything to be nice and smooth. So this is a pretty good this is a deck stairs, but you could consider this for any types of stairs. So you can see how they cut their stringers. They got their toe plate. They poured a little bit of like a pad footing or like a strip footing for their stringers to sit on. They've got a anchor bolt right here. And then they've also protected all their stringers. They backed them with a 2x4. And I strongly recommend this, because right here at this little corner, when you go cut your stringers out, right here at this corner, you can or will get in the future cracks. That'll crack right through that spot. So if you go and what they call is like strong back it, or just add some additional strength to it, is a lot of guys will come in here and they'll just add a 2x4. You can kind of see how they're in each of these. And they've just run a 2x4 on the inside. You can't see it once you put your treads and your risers on, and it just gives it that much more stability. You can kind of see right here, they have a metal clip right here. It's an attachment there, and it comes down and hooks right in here. I'll try to make sure to put a picture here down below of what one of those metal stringer to header connection metal clips looks like. They're pretty simple. You can find them at the box stores, and you just nail them on and then set the stringer in there and nail off the tabs on the side. Gives it a little bit extra strength. And then you can see they've kind of shown what would be some type of a landing, whether or not it's a paver or concrete or something like that. So this is a great illustration of stairs. It's really important to do your measurements before you cut, because like I said, your upper and your bottom riser can change based on what your materials are, and taking into account your decking for your deck or your carpet, or the bottom maybe is laminate, and then you have carpet stairs. So just kind of take all that stuff into account when you're putting it all together. So stairways shall be not less than 36 inches in clear width at all points above the permitted handrail height, and below the required headroom height. The clear width of stairways at and below the handrail height, if you have one handrail, is 31.5 inches. And if it's installed on one side, and 27 inches where the handrail is installed on both sides. So when it comes to the width of your stairs, just plan on 36 inches. End to end, right? You need clear 36 inches, and then you go add your handrail and you're good to go. So if your landing has to be 36 inches deep, and your stairs have to be 36 inches wide, which is the minimum width of your landing, you're going to have a 3x3 landing at minimum. Now, if you go install, say you go install a deck and you've got kind of wraparound stairs, so you can kind of walk down anywhere you want. Well, technically, you need a landing all the way around that. So 3 foot out, pour yourself a sidewalk or slab, or put in some pavers, a lower patio area, so that you're stepping on something solid. And that's just more of a tripping hazard. If you have just grass, well, if you mow the grass or you don't mow the grass, or you added rock beds or whatever that can rise and run, or snow or freeze, and then all of a sudden it could become a tripping hazard. So keep that in mind. 36 inches wide minimum, and then you're going to get your handrail, and it can be down to 31.5 or 27, but a handrail, most likely, you know, it's only going to stick out 3 inches or so, and we'll dive into that on the next video. Okay, so let's look at code. So here is headroom. We talked about 6'8" minimum, right? It says exceptions where the nosing of the treads at the side of the flight extend under the edge of the floor opening through which the stair passes. The floor opening shall not project horizontally into the required headroom more than 4.5 inches. Okay, makes sense. Bottom line, just stick with 6'8", okay? Try to make sure that from any point walking down those stairs, if you've got a tape, you've got 6'8". Vertical rise, a flight of stairs shall not have a vertical rise larger than 151 inches between floor levels or landings, just 12.5 feet. So if you got a shop and you have a loft or something that's way up there, let's say it's 13 or 14 feet, well, you're probably gonna have to put a landing mid-run. So you'd go about halfway, you'd put a 3x3 landing, and then you would go again. And that landing is a break in the stairs, okay? Here was the stair treads and risers. So risers, the riser height shall not be more than 7 3/4 inches, like we talked about. And it said the greatest riser height within any flight of stairs shall not exceed the smallest by more than 3/8 of an inch. Like I said, just in that full flight, you can't have a difference of more than 3/8 of an inch. So your bottom riser can't be 6, and your upper one can't be 7. It would have to be 7.5 on the whole run, but maybe the bottom one was 7.25. Then you only have 3/8 of an inch difference. Treads. The tread depth shall be not less than 10 inches. Tread depth shall be measured horizontally between the vertical planes of the foremost projection, which is just essentially saying that you need 10 inches from the riser to the edge, right? You need a 10-inch tread from the nose to the back riser. And then nosings, here's nosings. So nosings at treads, landings, and floors of stairways shall have a radius of a curvature at the nosing of not greater than 9/16. And it says a nosing projection is not less than 3/4 and not more than 1.25 inches. So you need to have that nosing, and it needs to be at least 3/4 or 1.25 inches. And then here's the landings, right? There shall be a floor or landing. So if you just come up on a floor, that would be considered your landing. At the top and bottom of each stairway, the width perpendicular to the direction of travel shall be not less than the width of the flight served. So again, as wide as the stairs. And then it says where the stairway has a straight run, the depth in the direction of travel shall not be less than 36 inches, right? So 36 inches. Now, obviously, if you're turning a corner or something, you'd have to go 36 straight out, and then you'd have to turn 36, and, you know, so maybe it'd be a 3x6 if you went down, turned, and then went down again, because you need a landing at the top of the next run of stairs, just as well as you need one at the bottom of the run that you just came down. It says, here's one exception. A floor or landing is not required at the top of an interior flight of stairs, including stairs in an enclosed garage, provided that the door does not swing over the stairs. So if you're in a garage and your door swings in, you don't necessarily need a landing on the outside on that run. You can just step and go in. If it pulls out, you want to have a landing to step on and open that door. A walking surface of treads and landings of stairways shall be sloped not steeper than 1 unit vertical and 40 inches horizontal. That's just simply saying that if you got a landing and stuff, or your treads themselves, you don't want your treads sloped. You don't want your landings sloped. You want them pretty much flat, right? The rise and run is the drop in the riser. Okay, so that should cover stairs, but I did want to touch a little bit on ramps. Sometimes if you have someone with special needs, or you're in a situation where you just would prefer a ramp over stairs, here's just a quick code reference on ramps. And in a nutshell, ramps are usually a 1 in 12, meaning that for every foot you go, you can drop 1 inch. 1 in 12, down 1 inch. So if you have a 5-foot ramp, the ramp can slope 5 inches. Ramps serving the egress door required by section 311 shall have a slope of not more than 1 unit vertical and 12 units horizontal. Other ramps shall have a maximum slope of 1 in 8. I would just stick with the 1 in 12. There is, like I said, where there's technical infeasibility to comply because of site constraints, ramps shall have a slope of not more than 1 in 8. So, which is fine. If you're in a situation where you just cannot get 1 in 12, well, there's your exception to go to 1 in 8. But that's pretty much what everything else would stay in line. You'd need a handrail, you need guardrails, you need landings, all the same components. Just if you're building the ramp, make sure it's structurally sound and try to stick to that 1 in 12 ratio. So again, back to this detail, we touched on ramps, and we kind of went over stairs, so you have an idea on what the riser heights, the treads are, the head height, the width. Now you should be good to go as far as working on your set of stairs. I think I've covered everything that you would need to get through that component. So on the next video, we'll dive into handrail and guardrail and when that's required. Okay, so now you should be good to go on stairs, right? We've talked about landings. We've talked about minimum 36-inch width. We've talked about your riser heights, your treads, your head height, making sure it's structurally sound, stringers, using a toe plate, using a metal connection at the top, and we've touched a little bit on ramps. So this particular point, whether or not you're messing with existing or you're building new, you should be able to make sure that you design them properly and that they will meet code requirements. And so in the next video, we'll hop into guardrail and handrail and when those are required on stairs.